All right, so today's objective, we're still working on finding zeros of polynomial functions. That is the main objective. So what do you want to be able to do at the end of the day? Find zeros of polynomial functions. Here's a couple of things that we'll use. We'll talk about using the rational zero theorem. We'll find zeros of polynomial functions, solve polynomial equations, use linear factorization theorem to find polynomials with given zeros. And if we have time for Descartes' sign change rule, then we'll get to that as well. Give you guys a minute, catch that up real quick. Mosquito bites. Mosquito bites bother me. Not all of us.
You can't say anything at the time.
I'm not. That's why I said it. Sounds kind of weird. Someone once told me, Mr. Munoz, you need to have a peanut butter and pickle sandwich.
Ew, that is good. No, I promise you, I tried it.
I tried it.
Hell, peanut butter and pickle.
Alexis eats sour cream.
Yeah.
Well, you know what? I'll tell you this.
We can't remember.
It was not like yum, and it wasn't like it was just like
Disrespect is what it is.
no. I do have to admit I kind of like the crunch,
Ew. Munoz.
but that's about it. All right, children. Are we good here?
No.
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 Don't knock it till you try it.
I like that it's gonna be on YouTube.
I know, right?
On my table. Maybe you should stop judging me.
Alright, now you're good.
Yeah, you can turn it on the way out. Your homework? What paper? Oh, we'll talk about it right now. But yeah, I definitely do want that. I guess the first time I said Wednesday, Adriana.
What?
Remember the first time I said Wednesday? Some people want to Wednesday. And yeah, you definitely want to get it. May I beg it? All right, let's do this. Alrighty. This is the rational zero theorem. It says, if f of x is equal to a sub n times x to the n power plus a sub n minus 1 times x to the n minus 1 power plus dot 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 a sub 2 to the times x squared plus a sub 1 times x to the first power plus a sub 0, it has coefficient integers of p over q, where p over q is reduced to the lowest terms, is a rational zero of f. And then p is a factor of the constant term, a sub 0, and q is a factor of the lead coefficient, a sub n.
Okay, now Matt don't like hard.
Math don't like hard. Here's what this is saying. Do you guys remember when we were talking about, yesterday I said, oh, you know what, they gave you a zero? Tomorrow, we have to find them? Okay. So let me tell you what this nastiness is saying. To find some possible zeros, you want to take all of the factors of the last value, and you're going to put them over all the possible factors of the first value. We're referring to this guy as P and this guy as Q. So here's what I'm saying to you, and hopefully you're looking at me. What are all the factors of, we're looking at all the P's over Q's. What are all the factors of 3? 1 and 3, right? We're going to choose positive, negative 1, positive, negative 3. What are all the factors of 4?
1, 4, 2.
So positive 1 plus minus 2 plus minus 4. So here's what we're saying. In order to find some possible zeros, you want to find every possible combination of these. So here's what I'm saying. I can try positive 1 over 1, which is what? 1. Or I can have a negative 1. I can choose plus or minus 1/2. I can choose plus or minus 1/4. You guys okay with that?
Yeah.
I'm using 1, and I'm combining them with the denominator of 1, 2, and 4. I should do plus minus 1 here as well. plus minus 1 here as well. But I can also have the options of plus minus 3, plus minus 3 halves, plus minus 3 quarters. So all I'm doing is building a bank of possible zeros. Make sense? No? Remember last time they said, hey, you know what? 1 is a 0. No, actually, we did one, didn't we? Remember right here where they said, oh, they told us that 3 was a 0? And we were able to go through this process? They're not giving us this anymore. They're giving us the polynomial, and we have to figure that out. So all I'm doing is building for myself a list of all possibles. This just says try. This just says try. Okay? Try. Is that a little bit better? Oh, look, we're done. We've listed all possible zeros.
You don't have to find them though?
No, not yet. Well, we will in a different slide. We should do that now. You guys want to try it out?
What?
We're going to do it anyway, right?
Yeah.
Find those zeros?
What is
Yeah.
it? Could we graph it for it?
Huh?
You
Could we
could.
graph it to find it?
No.
No?
This is a 5th degree polynomial. You could still be there for like 30 minutes. So, are we good, guys? We found all the possibles?
Yeah.
So at this point, we have 1, 2, 3, 4, 5, 6. We have 12. We have 12 possible. There's only going to be 6 of them, or 5 of them. Out of these 12, only 5 of them really work. Does that make sense? So, here's the way I like to do this. We're actually going to do this. It might come up on one of the different bullets, but we're just going to do it now. So, I'm going to start with my synthetic division. And I need my coefficients, which are going to be 4, 12, 0, 0, negative 1, negative 3. Someone double check? 5, 4, 3, 2, 1, none. Right? So, here's the fun part. Pick one.
One.
That's a great choice. That would be my first choice always, 2.
3/4.
Go back. Where'd it go now? Here we go. Okay, so let's start with by picking 1. So I've got 4, 4. What is this?
16.
I can't even plus. 16, 16, 16, 16, 16, 15, 15. I've got a remainder, right?
12.
So is this going to work?
No.
No. So, not 1. Let's try. Actually, you know what I'll do? I'll do a list over, I'll do a list like right down this side here. So these are knots. So it's not 1, right? Let's try negative 1.
Try negative 3.
Or do you guys want to try something different altogether?
Negative 3.
You guys want to try negative 3? I keep hearing people say negative 3. So, you are not going to do well in the non-calculator portion.
Excuse me, sir. I didn't use a calculator.
Negative 12, 0, 0, right? 0, 0, 0, 0, negative 1, 3, 0. So, yay! We got 1. So, negative 3 is a 0. Cool? We're good with that? Well, no. Well, you can graph it. But they're going to ask you for all this information. Okay? Don't shoot on me.
What?
You should put Desmos on a lockdown browser, please.
We're trying. I'm trying really hard. Okay, so we found 1, right?
Yeah.
So now what I'll do, I'm going to take all of these guys, not him, 4, 0, 0, 0, negative 1, and I'm going to try another one of my possibilities. Because this is, say it one more time.
Why did you take out the negative 3?
Because this one worked. This is a good one. I circled them, see? Yay, negative 3.
You just take out 12.
Why did you take out the minus 5?
What do you mean?
Like, so how the first one you have a negative 3, negative 1, negative 3.
There's 2 possibilities. I can try the positive version or the negative version. Now Lily graphed it, so she knew that negative 3 would work. So we did negative 3. We haven't tried positive 3. Would you like to try positive 3?
No, I just don't get why you take that out.
No, she thinks that you took it out because it's like somewhere at the top and bottom. You see how 4, 12, 0, 0, negative 1, negative 3.
No, I don't see. One more time.
Talk a little slower too.
So she thinks that we're using this down here. We're just using this one down here instead. She's asking why we're using this one and not this one.
Okay, so that's a good question. That's a great question, actually. Let me get rid of this for now, because that's a fantastic question. Now, do you see how this worked?
Yeah, I know.
So here's what we're saying. What I'm saying is that now, if I was going to rewrite this as a function, like up there,
Yeah.
it would look like this. It would be x plus 3, and then I would have 4x to the 4th minus 1. Because,
Wait, yeah, the zero isn't it plus? X plus 3 plus.
Okay.
no, because it's the opposite,
Oh.
right?
Oh, so you're gonna solve for the other zero.
So what I'm going to do is I'm going to solve for the other zeros. This produces a 0 for me, doesn't it?
Yeah.
So what I'm going to continue to try to keep going from here. Okay? Now, if you can see it already, then you know you can factor that, right?
Yeah.
Right? So I can go x plus 3, oops, wrong way. And this would give me what? 2x minus 2x squared minus 1, 2x squared plus 1. Right?
Factor that one out again.
And then, could I factor it?
Yeah.
Wait, no.
No. But what I could do, let me try this instead. Let's do, oh, I can't. I can't. So, what I'm going to do is I'm going to continue with my task here. I'm going to continue with my task. So I've got 4, 1, 2, 3, and then negative 1. What do you guys want to try next? Lily, did you have any other options?
1/2.
Really? You don't want to try the nice whole numbers?
No,
All right, he said a half. So let's go for a half. So I've got 4, 2, 2, 1, 1, half, 1/4. Nope, that doesn't work. So he's going to go in my, what?
-1/2.
What's 3/4?
Try it.
Try it.
Oh, try it. I was going to just add my 1/2 here to my not list so I don't do it again. Because you will probably end up doing it. What did you want? 3/4? Let's do 3/4 then. 3/4. So I've got 4. 3 times 4 is 12. 12 divided by 4 is 3. Right?
Yeah.
So that's going to give me 3. This will give me 9/4. 9/4. That'll give me 27/8. 27/16. My bad. I multiplied the top, but I added the bottom. That's going to give me 27/16. And then that's obviously not going to be 1, right? That's obviously not going to be 1. So I can discard 3/4. Okay?
Try negative.
All right. Anyways, we good with the idea of what's going on?
Yeah.
All right, cool. Let's move on because we got to finish this. We'll probably get a nicer one later on. Like this one. Find the zeros. So, and the other one, all we cared about was creating that bank, right? So what I want you to do right now is to create a bank for me. Create a bank for me. Create all possible zeros, please.
Mr. Williams, why is it the first one and the last one?
Why is it the first one and the last one? I don't know.
It just is.
You always got the great questions.
Oh. It's the have one more to each one. Oh yeah. I forgot the plus or minus 1.
The only thing I can think of, like off the top of my head, you know how when we FOIL and we're trying to factor, we always really care about the first and the last one because that's what's going to make the middle stuff.
Oh.
So the first one and the last one will produce values that we need, and then combinations will produce the middle ones. Right? That's what would make sense in my head. How many options did you get? 4? 4. And there should be plus or minus 1, plus or minus 2. Well, that's easier, isn't it? So we've got 1, 1, negative 5, negative 2. What do you want to try first? I heard 2. So I've got 1, 2, 3, 6, 1, 2, 0. Yay!
I didn't even grab that one, I swear.
So we've got 1 is a 2. Now, do you guys want to factor at this point?
Yeah.
Because we can, right? Now that's an option. We've got x squared plus 3x plus 1. Ooh, are we going to be able to do that?
No.
No. So we'll continue with our method. We'll continue with our method. 1, 3, 1. What do you guys want to try now?
Negative 2.
The 1?
Negative 1.
Negative 1. So I've got 1, negative 1, 2, negative 2.
No.
That didn't work, did it?
Nope.
So knots. I'll put knots right here. You guys want to try 1?
Doesn't work.
What doesn't work?
1.
Negative 2?
Yeah.
We'll try the negative 2 then. So we've got 1. That's going to give me negative 2. That will give me 1, negative 2. That didn't work either. So what conclusion can we draw? The only thing that worked was 2, right? That the other 2 are not real solutions, that they are imaginary. And how can we get those? Because we still need to produce them, don't we?
Yeah.
Nice and loud?
Oh,
You just said, it was like a alley-oop. Yeah, you'll have to go with the quadratic equation. So,
Will we go from
x equals opposite b.
plus or minus square root of b squared minus 4ac all over 2a.
So we've got,
When
what is
did
this,
we
3,
learn that?
3, 1, 1, 1.
We'll go. Okay.
Negative 3 plus or minus something over 2. We've got 9 minus 4, so that's, whoa, that's not imaginary.
Whoa.
You spoiled 5, dude. It'd be the square root of 5. Is that even a valid?
Whoa, bro.
No.
So we do have why for it no work?
What if we try going with the original problem?
You can't quadratic the original problem. That's why we quadratic this guy. So this gives us radical 5.
Yeah. Those would be your other 2 solutions, by the way.
Wait, so you got negative 2 and then.
Why doesn't it work?
Because in order for it to be imaginary, the square root would have to be a negative.
That's bothering me.
Did we have it in order?
Solutions is 1.
Yeah.
3, 2, 1, none. 1, 1, negative 5, negative 2. Bro.
Yeah, confusion.
Plus or minus 2.
I either do that or just to make to check for my.
There's only 4 options.
Like, if it's on my final check, then I'm.
Huh. Alright.
I do it for my final check.
Alright, let's move on then. Here we go. Properties of roots of polynomial equations. You know how sometimes when you do the imaginaries, or when you get imaginary roots, you'll get some complex number that's like a plus bi, right?
Yes.
What this is saying is if you have a plus bi, then more than likely you also have a minus bi. So we're just going to cut through all the fat here, and this is what this is saying. That conjugates usually come in pairs. Or sorry, the imaginary usually come in pairs. If you have a positive, then you'll also have a negative version along with it. Okay? Questions on that? Well, let's do it again. Here we go. Go for it, guys. I'll let you try that. I'll give you guys a few minutes. Like 2. Timer uppercut.
Oh, that's the first, yeah.
Is it AC on or something?
No. Solve it. It says solve a polynomial equation, so you can solve it.
I mean, don't you have like. Yeah. Plus or minus 1 right there. Possibles. Start with 1.
distribution?
No.
Okay, so let's see here.
One word. Number one.
So we should have plus minus 1, plus minus 13.
Yeah.
That's it, right?
Yeah.
Over plus minus 1.
Over.
Well,
plus
that's what they'll be.
Yeah, yeah, but that's what.
So let's go here. We got 1,
None of the
Thanks.
13s are-
1, negative 6, 22.
I have a question.
What's up?
Number one. Why aren't there fractions like there was in the first example?
Because your P.
Yeah, because all of our P's over Q's are just whole numbers. I think it has to do with that being prime.
Oh.
Might not have anything to do with it. Just me making conjecture here. So, what'd you guys try first? And what worked?
Positive one.
The positive one worked? So we got 1, 1, negative 5,
It'll be negative 5.
negative 5,
And then you'll get 17,
17,
17, and then negative
13,
13, and then you get negative 13.
13,
So you
0.
get
So that worked. So this is good. Now I'm going to go take that. 1, negative 5,
And then
17, negative
one.
13. Do I include the 0?
No.
No, that's remainder.
That's, that
And
did
then what'd you guys try next?
Negative 1.
Did it work?
No.
Negative 1 didn't work?
Nope.
So we got 1, negative 1, negative 6, 6. What is this? 20,
It's a 23.
24?
3.
23? And then you've got negative 23, and that didn't work? So negative 1 is bad. And then you guys tried 13, and 13 didn't work?
13 did not work.
So 13 did not work. Let's see here. So that's 1, 13, 8, big number. Big positive, not going to work. And then the negative didn't work either, right?
Yeah.
All right, so where are we left at?
Just positive 1.
We still need to find 3 more.
Right, so where are we left at? So our degree was 4?
Yeah.
So we're at x cubed,
Minus 5x
x squared plus 17, x minus 13. So at this point, let's see here.
Can we graph it?
Oh, we can factor it.
That's what I was thinking. Can we factor by grouping?
Yes. No. Because 17 and 13 don't have anything.
It has 1. We can take out 1.
But we should be able to keep going. Why for you let me down? Am I not seeing something? Nope, those are all of our possibilities, right?
Yeah.
13. Hold on, let me see. Maybe I missed something. Let me look at my notes here. And we said 1 worked?
Yeah.
Yeah.
Positive one.
Only positive 1.
Only a positive one.
Only positive 1? Did anybody ever retry 1 again?
No. What? Multiplicity. Oh.
Wait.
Multiplicity?
Oh.
So it looks like we have some multiplicity going on, don't we?
Yeah. I didn't think of trying that.
So now we're at x squared minus 4 plus 13.
Minus 4x.
Thank you, thank you.
You're amazing.
So does that factorable? No, because 1 and 13 is the only thing, right? So we got to go x equals.
Opposite b plus minus square root b square minus 4ac all over 2.
All over 2a.
Distracted me.
That's like,
So we've got 4 plus or minus something over 2. That's
That's
16 minus 40 plus 12. 52. Negative what? Is that right for starters?
36.
Negative 36? 6 times 6 is 36, isn't it?
Yeah.
So this is going to be 6i. So we've got 2 plus or minus 3i. Oh look, there's our conjugate pair again.
Oh wow.
So that means that x is equal to 1, 1. I'm just throwing it in just for simplicity's sake. Plus or minus 3i. Actually, I shouldn't even put this in there, but I should know that there's duplicity here.
Yeah.
Right? That's good to know.
That's
What degree was it?
4.
Yeah, there we go. 1, 2, 3, 4.
Damn.
That's cool.
That is really cool. I like that problem a lot.
Should check
I
my
know.
notes. Oh yeah, there it is.
Order mine.
1, 1, 2 plus minus 3i. Are we good there?
Wait.
I can wait. Yeah, once you get to that square level,
Can you post
don't
these?
waste your time doing synthetic. Do quadratics or go. Sorry, do factoring or go quadratic.
Can you post these on Black Lab or something?
Oh, I forgot about that. You mean the notes? Yeah, it's also immortalized in the world of YouTube.
Oh yeah. Immortalized.
Immortalized. I like how you use that.
Are you talking about barbecue sauce?
They're old.
Barbecue sauce on pancakes.
Gross. That just doesn't sound appealing.
So are they called barbecakes?
It's waffles, isn't it?
Oh, yeah, touche, never mind. Yeah, not pancakes.
They're waffles.
Now I want buttermilk pancakes.
Ooh, that sounds good. I want cream of wheat.
Are we done here? The Cinnabon?
Huh?
Cinnamon stack.
Change the slide. Moving on. Okay.
You like cream of wheat?
Cream of wheat is good.
Oh, I knew that.
Alright, so,
Only when my grandma makes it.
which is gracious. You guys remember when we did our linear factorization?
Yes, sir.
That's all this is saying. That's good. That's our objective, right? Because each one of those would give me a 0. Okay, really quickly. I want to try to get this last one in Descartes' rule. Descartes' rule. Descartes' rule, rule of signs. Here's what it says. There's 5 minutes left.
We'll be alright.
Exit ticket.
Yeah, no, I want to have time for that. Here's what this is saying. You want to count the sign changes. See how this goes from positive to negative? And negative to positive? That's one sign change, isn't it? Then I've got 2, 3, 4 sign changes. That means that I can have at most 4 positive,
I remember this, yeah.
4 positive solutions. But then they also drop down by pairs. So it could be either 4, 2, or none. 4, 2, or none. Now, to figure out how many negatives I would have, I need to plug in a negative x, get a new function that probably looks like this guy, and then I would count its number of changes. So it goes, looks like 1, 2, 3, 4. Doesn't help very much also, but that's what you would do for the Descartes.
Wait, that would be. There's only 3.
There's only 3 changes?
Yeah.
There's 1 change, 2 changes, 3 changes, 4 changes.
But that'll be positive to positive.
Where goes positive to positive?
Because it'll turn into positive 150.
It goes from positive to negative, right? That's 1 change. Goes negative to positive, that's 2 changes. Positive to negative is 3 changes, and then that's 4 changes.
But when you factor the negative.
Oh yeah, once you plug in the negative, yeah, it would change things around, yeah. So you're still counting the same, and that gives you the possibility of negative ones, okay? All right, guys, I think there's still time for you guys to take it. It only takes about a minute. Let me turn this off. You can do it on yourself.